2 cosine of x over 2 minus radical 2 equals 0. Okay, part A, I want you to solve this between 0 and 2 pi. This is different from the problems from last week because my angle is not just an x. That is the only thing that's changing today. I'm going to put other things with our angles. Let's start like we just did on the problems we worked out. So if I want to get my cosine by itself, you would add over your radical 2, divide by 2. Okay, from here, if cosine is positive, what quadrants are we in? Thank you. Reference angle. When is cosine radical 2 over 2? We are in radians. Pi over 4. Okay, so our angle, which is x over 2, equals, in quadrant 1, pi over 4 is pi over 4. In quadrant 4, pi over 4 would be 7 pi over 4, right? Double minus 1. Okay, if I want to get x by itself, what would you do? So you have to take everything times 2. So that means x equals 2 pi over 4, which would reduce to pi over 2, and 7 pi over 4, which is 7 pi over 2. Okay. Part A. Every answer between 0 and 2 pi. Pi over 2 is between 0 and 2 pi. Is 7 pi over 2 between 0 and 2 pi? No. 7 divided by 2 is 3.5. So that's too big. So part A, the only answer between 0 and pi over 2, or 0 and 2 pi, is my pi over 2. For part B, we have to think back. Remember when we did graphing in chapter 4? And whenever there was something with your x, it changed the period of the graph, which is how long it took to repeat. And so we always said your period was the normal period. So for a sine, cosine, that's 2 pi, divided by the number in front of x. X over 2 is like a 1/2 x. So this one would have had a period of 4 pi. Okay, what that means, you don't have to draw all of this, but if you were graphing cosine, remember we did our count bys. This graph of cosine would have looked like this. If I did cosine of x over 2. So that's why when I want to know every time it equaled positive radical 2 over 2, we can see that only happened once between 0 and 2 pi. But if I want every possible time, this graph keeps repeating. How long does it take until it repeats? Normally, in the last section, it was always 2 pi or 360 degrees. But if you change your period, that changed how long it takes to repeat. So we have to add 4 pi k. And you do use both of your answers on this, where k is an integer. So the difference today, our angles are not just x's. So if we think back to our graph, that means it changes the period of the graph, the length of time until it starts repeating. So we are going to have to take that into consideration when we write our final answers. questions there? Let's do another one. Okay, so we start out solving like normal. Get your trig function by itself, which this one already is. Okay, when is sine negative 1?
Quadrant 3 and 4.
It's negative in 3 and 4, and it equals the 1 right between them. So it's at 3 pi over 2. Okay. This problem has a trick to it. So I'm going to talk about 2 different options for this, and then you guys can tell me what you like, okay? If we think about graphing in chapter 4, when we graph sine 3x, your period is 2 pi over 3. So when you go to graph that, you do your count by, divide that by 4, so we have pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3. Okay, so I can see that hit my negative 1 time. However, if I said every answer between 0 and 2 pi, if I kept going, if I kept adding pi over 6, it would be 5 pi over 6, 6 pi over 6 is just pi, 7 pi over 6, 8 pi over 6 is 4 pi over 3. I'm not to 2 pi yet, so I could keep going. 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6 is 2 pi. If you kept repeating this, how many answers between 0 and 2 pi do I actually have? 3. It hits the negative 1 3 times. So let's talk about how we can get those. 2 ways. What I want you to recognize from now on, what I will do, when I look at this, if that is a 3, that means my graph will repeat itself 3 times in that interval. So I will have triple the solutions. In other words, if I had asked when this graph equaled 1/2, it would be a positive 1/2 here and here, here and here, here and here, and we would have got 6 answers. So it will give us triple the answers because it's a 3. If it had been a 2x, that means our graph would cycle through twice, so we would have double the answers. If it was a 4x, it would cycle through 4 times, so I would have 4 times the answers. For how to get those, there are 2 ways. Option 1, since I have 1 answer and I know I need triple, that means I need a total of 3. If you start here, you can add 2 pi to each of these to get the remaining answers. So 3 pi over 2 plus 2 pi would be 7 pi over 2 plus 2 pi is 11 pi over 2. Then what would I need to do to all of these to get x by itself? Multiply by 1/3 or divide by 3. So x would equal pi over 2, 7 pi over 6, and 11 pi over 6. If we look at our graph, pi over 2, 7 pi over 6, 11 pi over 6. Those are the 3 times it happened. So that is the first way. You have to know how many answers you need, and then you just keep adding 2 pi until we get all of them. So if it was a 5x, you would get a total of 5 answers there. You keep adding your 2 pi. Option 2, if you prefer, you can solve for x first. And then we can use the period of this graph. We said the period was 2 pi over 3. So if you solve for x, then you add your period to get your remaining answers. So if I added 2 pi over 3, I get 7 pi over 6. Add 2 pi over 3, I get 11 pi over 6. Both ways work. In general, I think most people prefer the first way because you add the 2 pi every time and you don't have to remember to calculate the period and add that on. But the second way may give you some smaller numbers to deal with. That's really the only change. How do you guys want me to proceed with these? The first or the second way? First way? Okay, so we'll just add 2 pi to get all of our answers and then divide them all. Okay, so then part B, that was the answer to part A. Part B said all possible solutions. Anytime I say that, you have to take your original answer for x, which was just the pi over 2, plus your period times k. And we said this time our period turned out to be 2 pi over 3, k. On these, most of the time I'm going to ask for the answers like part A, between 0 and 2 pi, so you won't have to worry about that. But occasionally, if I did say all possible solutions, you just take whatever you originally got for x and add your period to it. So that tells me every multiple. And we'll add 2 pi over 3 every time we come around. We'll get another solution. Okay, let's look at another. Okay, if I want to solve this between 0 and 2 pi, we have 2 issues. We have 2 different trig functions, first of all. We have sine and cosine. But the second issue is the angles don't match. One of those is just sine of x, and one is cosine of 2x. Technically, we can deal with either one. If I do the 2x, then I know I'm going to have double the solutions at the end. Or, if we want to keep the sine of x, we need to figure out something to replace it with. When you have something like this where the angles don't match, that's usually when I would go to my formula sheet. Cosine 2x, that is a double angle. Look at your double angle formulas. We had 3 of them. What would work for cosine 2x? And that is probably the best option because it has the sign in it and nothing else. So this is a quadratic. We set it equal to 0. We prefer our squared term to be positive, so I'm going to add over my 2 sine squared x. What would we do here? We can do box method. Can I do the shortcut? No, so we have to draw it out. Okay, so multiply to -2 and add to +1. +2 and a -1. Okay, set each of those equal to 0. So the first one add your 1, divide by 2, so sine x equals 1/2. Second one, subtract your 1, so sine x is -1. If I'm looking at these, both of my angles are x, so do I have to worry about the new things that I was showing you today? No, these are like before. If your angle is x, you're just doing normal answers. So sine is positive in 1 and 2. Reference angle, we were in radians, so sine is 1/2 at pi over 6. So pi over 6 in quadrant 1 is pi over 6. In quadrant 2, it will be a 5 pi over 6. When is sine -1?
At 2, that'd be 3 pi over 2.
And since it's already x equals, those are my answers. We don't have to do anything else. Alright. I'd like to do maybe one more, and we can stop for today. So I want to solve this one on the interval 0 to 2 pi. Okay, what would you do first?
Divide by radical 2.
Okay. So if you divide your radical 2 over, you get cosine of 2 theta equals -1 over radical 2, which is the same as radical 2 over 2. Now you could use a double angle formula, but we don't need to. When I see that 2 theta, what does that tell me first of all? We will have double the solutions. Okay, now let's think about this. When is cosine negative? Reference angle, when is cosine radical 2 over 2? 45 degrees, which is pi over 4. So 2 theta would equal, in quadrant 4, pi over 4 would be, in quadrant 2, that would be 3 pi over 4. In quadrant 3 would be 5 pi over 4. I have 2 answers. Since I said double, how many should I get? 4. How do I get the 2 remaining answers? We add 2 pi to each of the answers that we have. So 3 pi over 4 plus 2 pi, that's like 8 over 4 plus 3 over 4, so 11 pi over 4. 5 pi over 4 plus 2 pi be 13 pi over 4. Those are all my answers, but I need theta, so what do I have to do to all of them? Divide by 2. So 3/4 divided by 2 would be 3 pi over 8. 5 pi over 8. 11 pi over 8. And 13 pi over 8.
What did you do?
To get the 8s, I divided each of them by 2, or take them times 1/2.
The 3 over 2, I mean
The third,
yeah.
I added 2 pi to my 5 pi over 4.
And then you took the 13 over 2 or 4.
And divided by 2.
Okay.
Other questions? I think we are going to stop here for today. So I'm just giving you a couple problems to try tonight. Tomorrow we'll do some more examples and add more problems to this assignment. So you have 4 problems right now.